Alright, Mr. Claxton's Algebra 2CP class. For those of you who might have been absent today or didn't get enough time to check last night's homework, you could pause right now to check 25 to 33 all. You also had 40 and 42 to complete. So you could pause right now in order to do that. Remember, we did go over our goals, and the main goal here is that we are solving the systems of linear equations exactly. We've taken care of the approximate solutions with graphs. We are solving them exactly. That is very important. Very important because we are going toward solving a linear equation and a quadratic equation. When we get there, you'll be just fine. We didn't do the graphing example in class. We are going to go back and do that. But it is very important that you know how to solve a system by graphing, and that's just an approximate solution. That's not an exact solution. You should also know of the three possible solutions that there are. And this is how we classify. We classify them in this rightmost column here. That's the classification. Very important that you know with this classification system. And by the way, we are just going to use independent, dependent, and inconsistent. If you use independent or dependent, you'll know that it's also consistent. You'll know that it's consistent as well. So make sure that you're not getting confused on that. We are just going to stick with independent, dependent, and inconsistent. Alright, when there's one solution, we know the lines intersect at one point. The slopes of the lines are different. It doesn't matter. The y-intercepts do not matter. When it has many solutions, you know the lines intersect at many points. In fact, we like to say infinitely many. We know the lines are exactly the same. That means same slope. And because I don't have room, I'm just going to put an M. And same y-intercept, b. And that comes from y equals mx plus b. When there's no solution, we know the lines do not intersect, ever. That means they go on and on forever and ever. They never intersect. That means they're parallel. We know the slopes are the same, and then the y-intercepts are different. Crucial right there that we prove the y-intercepts are different. Because if the y-intercepts are not different, then they're the same, okay, that would mean many solutions. So we must prove the y-intercepts are different. Alright, this will help you for a later slide. Let's go ahead and take a look at what we did in class today. We talked about solving by substitution. I was very confident in what everyone knew at the end of class. First thing we did is we grouped that together, made that a system of equations. We are solving for y. Okay, we are solving for y. And some people are going to need to do side work for that. In this particular example, equation 1, the top equation there, that is the best equation to solve for y. How did we do that? Well, 4x minus y set equal to 16. What we had to do was subtract 4x on each side and then divide by negative 1. And dividing by negative 1, there were a couple people that forgot that. We substitute, you see the blue there, we substitute it into the other equation. You must substitute it into the other equation, perform the distributive property to get x equals 3, and then we plug it in. Plug it in to one of the original equations. The solution is xy, and I confirm that over here. Okay? This is where we prove it. For the next example for all, anyone who didn't get this should definitely be watching this video, or should have sought me as a resource or some other resource. in order. Khan Academy, another student, the notes. So it's much easier to solve this equation 1 for y. So I'm going to go ahead and do that, equation 1 for y, and I'm going to use that. I'm going to use red. Solve equation 1 for y. Subtract 2x on each side to get y set equal to negative 2x plus 3. Don't know why my pen keeps doing that. Negative 2x plus 3. All right. Once we get that, we can substitute the quantity, negative 2x plus 3. We're going to substitute that in for the y there. So when we rewrite what's sometimes called a master equation, equation 2, right, 3x minus 2, and then we just plug that quantity in. Negative 2x plus 3. We must remember, absolutely must remember, to set that equal to 8, because after all, we're trying to solve an equation here. In fact, we're solving a system of equations. Distribute that negative 2 through, distribute that negative 2. A lot of math teachers use the arrows, which have no sound mathematical meaning, but if it helps you to remember, use it. So we have negative 2 multiplied by negative 2x, 3x, plus 4x. Negative 2 times positive 3, that's where we're going to get the minus 6. Okay, because that's negative 6, which I could say is just minus 6. All equal to 8. Combine like terms. Determine the x value. 7x minus 6 equal to 8. All right, add 6 to each side, divide by 2. At that point, I know that you can do it. You're going to get x equals 2. You're going to get 14 over 7, which is 2. Back substitute. So now we back substitute 2 into, or plug it in, back into. You can plug it into equation 2 if you want to. You can plug it in to equation 1. I always like to choose wisely. Because I know that I did a good job converting that equation, equation 1, I might back substitute it into the solved version of equation 1, but I'm going to go ahead and back substitute it into the original version of equation 1. And gives us 2 multiplied by 2 plus y set equal to 3. All right. 4 plus y equals 3. Subtract 4 on each side to get y equals negative 1. So for anyone struggling with their assignment, which, here we go, negative 1. For anyone struggling with their assignment, just make sure that you are following these steps for substitution. I do list the solution to that alternate. Remember, this is for the advanced. If you got that one wrong, try the alternate example 1 if you got this example wrong. Okay, then go straight to alternate example 1. And use the check step. We always want to use that check step to solve it. Let's put the finishing touch on it just to make sure we're right. You know, 2 times 2 plus negative 1 is 3, and 3 times 2 minus 2 times negative 1, you know that's 8. Minus negative, same as plus positive. Thank you very much for watching, and enjoy solving systems of equation by substitution.